to start recording and sharing my screen. And so today we're going to look at those application problems, those word problems. We're also going to solve something that I've always heard called literal equations. I have to apologize. I'm not positive if Mr. Blitzer used that phraseology in his textbook or not. It's just something that I've always heard referred to as literal equations when you're solving an equation in many variables for one variable in terms of the other. Before we start that, homework 1.1 is due today. Homework 1.2 isn't due for a while, but please work on both of those because there will be a quiz over the weekend. It's in my math lab. You have to put your work into Blackboard. It's 4 questions from homework 1.1 and 1.2. It will be due by the end of the day on Sunday, and it will be available after class of today, so from 2 o'clock on. Before we start looking at that new content, which is what will be in homework 1.3, pardon me, does anybody want to look at any of the questions from homework 1.1 or 1.2?
I have one I'd like to look at.
Enough, Nicholas, which one?
It's an easy one. I just wanted to make sure I did it right. It's number 5.
In 1.1 or 1.2?
1.1.
Okay. And unless there's a lot of other questions, what I did for my Tuesday, Thursday class yesterday was I started by kind of just going over from the homework examples, like what you might see on the quiz over the weekend. Is that something that everybody would like or no?
Yeah.
Okay. Here we want to plot the point 5 halves, 7 halves. And what makes this one a little bit challenging is that we have those fractional coordinates. But as I look at my graph paper here, the grid, do you see that there are 2 blocks for each number? And so when I move over a block, I move over a half. So 5 halves on the x-axis would be like moving over 5 blocks, which makes sense because 5 halves would be 2.5. In the same way, 7 halves would be like moving up 7 blocks, or it makes sense because, whoops, the number 7 halves as a decimal would be 3.5 or 3.5. And so that's where I would locate that one. Is that what you were thinking?
I had actually divided by 2.
Oh, and gotten the decimals?
Yeah.
Yeah.
Does that work like that?
Yeah, it works like that. 2.5 would be midway between, 3.5 would be midway between. But you know what? I'm kind of lazy. As I look at the 5 halves, as I look at this grid, does it make sense that each block is a half? So 1 half, 2 halves, 3 halves, 4 halves, 5 halves would be moving over 5 blocks. Both give you the same approach. It's what's ever clearer to you. Okay. Does anybody want to look at any other questions in particular from homework 1.1? In terms of what you might see on the quiz, on the quiz, you're going to see something where you're given an equation and you're asked to complete the table of values and then pick out the graph. I would prefer it if you could actually physically do the graph, but in my math lab, questions like this, it's a multiple choice graph. How are you folks at completing the table of values for an equation and then identifying the graph? Is this something we need to go over, or is this a skill that you have already?
Do you mind going over it?
No, not at all. That's why I asked. So over here, You know what? The table of values, when I do it by hand, I like to make a column for X, make a column for the equation, and make a column for Y. And so if X is -3, this would be -3 cubed minus 3. -3 cubed is -27, minus 3 would be -30. Then they'll ask you for -2. -2 cubed would be -8, minus 3 would be -11. Then they'll ask you for -1. -1 cubed would be -1, minus 3 is -4. Then 0, 0 cubed minus 3 would be -3. Then they'll ask you for +1. 1 cubed minus 3 is -2. Then they'll ask you for 2. 2 cubed minus 3 would be 8 minus 3 or 5. Then they'll ask you for 3. 3 cubed minus 3 would be 27 minus 3 or 24. Then if I were doing this by hand, I'd plot those points with those coordinates. Again, in my labs, they're not actually asking you to physically do the plotting, but rather identify the correct graph. So let's see how we can do here. This will be -3. This will be 3. I'm going down to -30. So I guess I'll go up to +30. And because I'm doing it by hand, I'm going to wing it a little bit. At -3, it's -30. At -2, it's -11. At -1, it's -4. At 0, it's -3. At 1, it's -2. At 2, it's 5. And at 3, it's 24. And so then I would connect my points with a smooth curve. In my labs, they're not giving you the opportunity to show this work, which is why I'm asking that you put it on the table. They're just going to ask you to type those Y values in. Each time you put one in, the table will open further. And in my labs, they're not asking you to graph it by hand, but rather they'll give you a series of graphs to pick from, multiple choice, and hopefully you can recognize that as the correct choice. Is this doable? Is everybody, comfortable making the table of values? Did anybody have any other questions from homework 1.1? If not, I'm hoping that you've started homework 1.2 because the quiz has questions like those in homework 1.2. One question is solving an equation that went too far, is chock full of parentheses. Let's go over one more. How are you folks at solving equations that look something like this? Is this something you need to go over, or are you comfortable? Anybody want to see this one done out or no?
I'd like to see it just because.
Okay. So what we've got here is 7 times parentheses x minus 8, close parentheses, minus 8 times parentheses x minus 7, close parentheses, equals x plus 7 minus parentheses x minus 4. Does everybody remember the first thing that we said we do in solving an equation is simplify each side? What would you do to simplify what's over here on my left-hand side? Anybody have an idea as to how to simplify that left-hand side? You guys are scaring me. I expected,
Distribute.
thank you, distribute. Distributing the 7 would give me 7x minus 56. Be careful when you distribute the 8, it's actually a negative 8 that you're distributing. And so when you do that distribution, you get minus 8x, and then negative times negative would be plus 56. And so combining there, 7x minus 8x is negative 1x. Negative 56 plus 56 is 0. Now we're going to do the same type of work on the other side. On the other side, though, what I have to distribute is that minus sign. And so again, I like to think of having to distribute that number negative 1. And so the x plus 7 remains. And then negative 1 times x is negative x. And negative 1 times 4 is positive 4. And so here, combining like terms, x minus x is 0. 7 plus 4 is 11. Then to finish solving, we'll divide both sides by negative 1, because again, we don't want to know what negative x equals, but rather what x equals. And that division would leave me with x equals negative 11. How was it?
Good.
What you have to remember is you need to distribute. When you distribute, watch your signs and be very careful when you combine like terms. After you've simplified each side, it should turn into, maybe not quite as easy as this, but it should turn into a much easier equation to solve. Can I erase this problem?
Yeah.
Then there is an equation like, oh, I'm going to guess around here. One of these that, whoops, not this one. Like this, where you're asked to solve an equation that's full of fractions, where the denominators are all numeric. If I look at x plus 5 over 4 is equal to 7 over 2 plus x minus 8 over 7. The denominators, again, are numbers, so I don't have to worry about values to exclude. Those denominators will never equal 0. And if I were brave, I could go ahead and solve that with the fractions. But am I correct in assuming that most people would like to try to clear the fractions before they solve? And so what you have to remember to do in order to clear the fractions is you have to remember to find the lowest common denominator. And between 4 and 2, it would be 4. And then if I add the 7 to the mix, would my common denominator be 4 times 7 or 28? Then I'm going to multiply both sides by that 28. I'll simplify what's on the left first. I can think of that 28 as being 28 over 1. I can divide 4 into 28 7 times. So I'm left with, on the left, 7 times x plus 5, which will distribute to get 7x plus 35. So far, so good. Then on the right, in order to multiply, I have to distribute. So I'm going to take that 7/2 and multiply it by that 28. And I'm going to take that x minus 8 over 7 and multiply it by that 28. Again, when I multiply a number by a fraction, I'd like to put it over 1. Here, 2 goes into 28 14 times. So 7 times 14 would be 98. And I apologize, I wrote that denominator wrong. That one's a 7. Here, multiplying, 7 can be divided into 28 4 times. So here I'm left with 4 times x minus 8. which would give me 4x minus 32. Once I've got it to that place where I've cleared the fractions, is everybody all right with finishing solving the equation? On the right, I can still simplify. 98 minus 32 is 66. I'm going to subtract the 4x from both sides to get all of my variables on the same side. I have to apologize, I've run out of space, so I'm going to scooch over here. That'll give me 3x plus 35 equals 66. Subtracting the 35 from both sides will give me 3x equals 31. And then when I divide, my solution will be x equals 31/3. Is that type of problem all right with everybody?
Yep.
Any questions? Then I'm going to clear it. And then the last type of problem that you're going to look at, see on the test, is something similar, but there will be variables in the denominator. So here I have an equation like 8 over 5x plus 5 is equal to 4 over x plus 1 minus 3 over 5. The first thing they're asking you for are values that make the denominator 0, which would be values to exclude. So if I look at that first denominator for 5x plus 5 to equal 0, subtracting, I'd get 5x equals negative 5, and dividing, I'd get x equals negative 1. Next one, if I look at x plus 1 equals 0, solving that would also give me x equals negative 1. Lastly, I'd have 5 equals 0, which I'm going to ignore because 5 will never equal 0. So with this problem, I only have to exclude negative 1. That's the only value that gives me a 0 in the denominator. Then, just like the last problem, to clear the fractions, we want to find the lowest common denominator. To do that, I'm going to factor this first denominator, 5 times x plus 1. And so my common denominator will need a factor of 5 and a factor of x plus 1. And then over here, well, we've already got that factor of x plus 1. And here we've already got that factor of 5. With me so far, folks? Am I talking too fast or are we good?
Good.
And then just like the other problem, we're going to multiply both sides by that common denominator. Over on the left, the denominator will cancel, and I'm just left with 8. On the right, I need to distribute. So that gives me 4 over x plus 1 times 5 times x plus 1 minus 3 over 5 times 5 times x plus 1. If I think of that common denominator as being over 1, this first product, the x plus 1's the common factor, would divide out. So that'll give me 8 equals 4 times 5 is 20. This second product, if I think of putting that common denominator over 1, the 5's would cancel out. So that will leave me with minus 3 times x plus 1, which would give me minus 3x minus 3. So that will become, moving over here, 8 equals 17 minus 3x. I'll subtract the 17 from both sides, giving me negative 9 equals negative 3x. And then dividing by the negative 3, I'll end up with x equals 3. And then I always want to compare that to the value that I must exclude, because 3 is not in the list of values to exclude. It will most likely check. Is that one all right? Any question? So the quiz will be 4 problems, just like those 4 problems we just looked at. Okay? If there are no questions, is it all right if I erase this? Not hearing concerns, I'm going to erase it. And did anybody want to look at any of the other problems from that homework, or are we all right? Before you take that quiz over the weekend, if you work on this homework, if you have any questions, please feel free to use that Ask My Instructor button to email me questions. On the weekend, I'm not always on the computer, but I will check it periodically, so I should get back to you hopefully within a reasonable amount of time. If I do not, please send me another email reminding me to get back to you. So if that's all right, let's pick up then with applications and literal equations. Applications are word problems. And so because word problems are wordy, I took the liberty of uploading a bunch of word problems into this document. I promise I will post both the written notes and the recording if you want to see the words of the problems so that you don't need to take the time to rewrite them right now. Let's start though at looking at those literal equations. And when I talk about literal equations, what I'm referring to is when you solve an equation in many variables, for one of the variables in terms of the others. And honestly, this is no different than what we've been doing, solving equations. We're going to use our properties of equality, that addition property, add the same thing to both sides, subtraction property. It's not a property of equality. Equation is property of equality, I'm sorry. And my pen stopped working. Let's try the other one. To isolate the variable you're solving for. And add the same thing to both sides, or multiply both sides by the same quantity, or divide both sides by the same quantity. except a lot of times instead of adding, subtracting, multiplying, dividing by numbers, it will be variables. And so I did upload several of these to the end of this application sheet. So I'm going to real quick open that up and look at them if everybody's caught up. Everybody in the same place? Oh, passed them. So let's look at this first one. We want to take that equation and we want to solve it for r. So we have c is equal to 2 pi r. And to say that we want to solve it for r means that we want to get that r alone. Again, we're going to treat this like we do other equations. First thing we want to do is get the term that contains the r alone on one side, which it is. Then we want to get that coefficient on r to be 1. Does everybody see the way this is written? I'm multiplying r by 2 pi. So I'm going to divide by 2 pi. And what I do to one side, I do to the other. Working that out then, 2 pi divided by 2 pi will leave me with just r. And on the other side, I can't combine those, so I'm going to leave it as c over 2 pi. Having seen that one done out, can I ask you folks to please solve v equals pi r squared h for h. So again, you're going to use those properties of equality to try to get the h alone on one side of the equal sign. Remember, whatever you do to one side, you've got to do to the other. Did anybody else get h equals v over pi r squared?
Yep.
Great. Next one's a little bit more involved. I've got p equals c plus mc, and I want to solve for m. Again, in order to get that m alone, we want to get the m term alone on one side of the equal sign first. So we have to move that c, that single c. Since it's being added, we'll add the opposite or subtract c from both sides. On the left, I can't combine them, so I get p minus c is equal to m times c. Now it's like the previous ones. If I'm trying to get m alone, the m is multiplied by the c, so I'm going to divide both sides by c. And so I can write that m is equal to p minus c over c. Or if you want to simplify that more, p over c minus c over c is 1. Either one of those should be acceptable. Next one's a little bit different. If I look at 48, I've got a equals 1/2 h times a plus b, and I want to get that b alone. There's a couple of different approaches that you can take with this one, depending on whether you see the glass as half empty or half full. Is there anybody else in the room that would like to first deal with that half? Because I'm looking to get b alone, I could distribute as is, but I think most people find it easier if we get rid of that half first, and we'll do that by multiplying both sides by 2. That'll give me 2a equals h times a plus b. And now to get the b alone, Would anybody distribute the h? 2a equals ha plus hb. Now it's kind of like the one we did previously. First, we have to get that b term alone. So I'll subtract HA from both sides. Be careful. If it's a lowercase a and an uppercase a, it's kind of case sensitive. We're not going to treat them like the same variable. So those are not like. I have 2a minus HA equals HB. And then to get B alone, wouldn't we divide both sides by H? Leaving me with B equals 2 big A minus H times little a all over H. How's that one?
Just 1 second.
Okay.
All good.
Okay, next one. 52 is a little bit different. I have S equals C over 1 minus R. We want to get that R alone, but that R is in the denominator. Well, that turns it into one of those rational equations, those fractional equations. And like the one we just did, to get something out of the denominator, remember we were going to multiply both sides by the least common denominator. Here, the only denominator is that 1 minus R. So I'm going to multiply both sides by that. So that'll give me S times 1 minus R is equal to, the 1 minus R's cancel and I get C. Before I go any further, I'd like to stop and have you guys look again at that original equation. In that original equation, I only have one fraction on one side. I only have one term on the other side. Could I think of that S as being S over 1? And now, does this look like something you might have seen previously called a proportion? And you remember a proportion, if it's just one fraction equaling another, does anybody remember learning that you could cross multiply? Cross multiplying would give us S times the 1 minus R is equal to 1 times C. And so if you just have that one term or that one fraction on either side, you could cross multiply to get that. If you're afraid, though, of making a careless mistake cross multiplying, or if you're not sure that you can, by all means, do what we did with those rational equations, multiplying both sides by your common denominator. Since we're trying to get the R alone, we have to get it out of the parentheses. To do that, we'll distribute. So that gives me S minus SR is equal to C. Then let's see, getting the R term alone, we'd have to subtract S from both sides, giving me negative SR is equal to C minus S. And then to fully isolate the R, we can divide by negative S. So we could get that R is equal to C minus S over negative S. Or if you want to be fancy and get the negative sign out of the denominator, we can multiply numerator and denominator by a negative. And we could say that that's R equals S minus C over S. I think it's perfectly fine if you stop here. But if that dangling negative sign bothers you, multiply both numerator and denominator by -1. Any questions on these literal equations? If not, let's go back to where we were writing notes and look at applications, which is a fancy pants way of referring to word problems. When I look at word problems, I'm going to go on the assumption that everybody has done word problems previously in their mathematical careers. The first thing that you have to do is make sure that you read carefully. No matter how many words are in that problem, you want to read it carefully. You want to read every word. You want to make sure you know what you're looking for, know what's being asked. And when you know what's being asked, know what information you need, what information you might not need. Then, some people like to solve problems by just guess and check, but this is an algebra class, so we're going to solve them algebraically. In order to solve them algebraically, we need to define our variable, or if we're looking for several things, variables. That might be something that you've seen before is a let statement. And because right now we only know how to solve an equation with one variable, right now, if there are more than one unknowns, we have to be able to express one in terms of the others. And we'll look at examples that involve that in a minute. In between, I'm going to add a step that I forgot to give the Tuesday, Thursday class early on yesterday. And it's the idea that sometimes, especially if it's a geometric problem, a picture is worth 1,000 words. Which is my way of saying sometimes you want to draw a diagram. And we'll look at one of those again in a few minutes. Then we're going to write an equation. When we do that, we want to look for keywords. Things like sum means add, difference means subtract, of, especially if we're looking at percents, tells us to multiply, and so on. Once we've got that equation written, we're going to solve our equation. And then when you do the check, I usually don't go right back to my equation to check because I've made up the equation. I want to make sure that I made up the right equation. So I'm going to check actually in the original situation. And so I am guessing that right now that might be as clear as mud. I'd like to look at several examples. let me know then if you're ready to go on to the examples. We ready? Can I turn the page, folks?
I'm good.
Then literal equations were at the end. Let's start looking at these applications. First question says, you need to rent a rug cleaner. Company A will rent the machine you need for $22 plus $6 an hour. Company B will rent the same machine for $28 plus $4 per hour. After how many hours of use will the total amount spent at each company be the same? What will the total amount spent at each company be? Okay, I don't think we need a picture for this one. What are we looking for? What's the first thing we're looking for? Anybody? Aren't we looking for the hours? So I'm going to let H equal the number of hours. Then I want to write an expression for what the charges would be at company A. Company A charges me $22 and in addition, plus $6 for every hour. Company B, what would their expression look like? Anybody there?
Yeah,
What would the expression for company B look like?
22 plus 4H.
28.
Thank you, though. 28 plus 4H. And we want to know when they'll be the same. Well, for them to be the same, wouldn't that be when those two expressions are equal? Now to solve an equation, because we have variables on both sides, remember we want to get all the variables together first. So I'll subtract 4H from both sides. Gives me 2.
He
20.
does.
You guys all right?
Met him in the class.
Yeah.
See, I need to pick the class up.
Anybody have a question? Are you guys talking to yourselves? Or I'm gonna. So that gives me 22 plus 2H. Is equal to 28. Then we want to get the H alone. We'll subtract 22 from both sides, giving me 2H equals 6. And dividing by 2, I'll get H equals 3 hours. So now checking, company A would be charging $22 plus $6 times each of 3 hours. So that would be 22 plus 18 is $40. Company B would be charging $28 plus $4 for each of 2 hours. And so that would give me, I'm sorry, each of 3 hours, I apologize. 28 plus 12, which is also $40. So the second part of the question, it would be $40 at each. And there's the same, so it checks. Any questions on that one?
Nope.
If not, the next one is somewhat similar. So I am going to be quiet and give you guys 3 minutes to work on that one. Did anybody else get that you would have to cross that bridge 20 times?
Yes.
Any questions on that one? If not, the next three all deal with percents. The first one says that after a 30% reduction, you purchase a dictionary for $30.80. What was the dictionary's price before the reduction? With a problem like this, if there's a percent, you want to be able to express the percent as a decimal. And so hopefully everybody recognizes that 30% is that decimal 0.3. Now, if D is the dictionary's original price, the reduction, the amount that we're taking off, would be 30% of that. 30% 0.3 of the means times D, the price. If it's the reduction, I'm taking the original price minus that amount, and I know that's equal to $30.80. So far, so good. Any questions?
No.
If not, then these are like terms. Realize that this D is a coefficient of 1, and 1 minus 0.3 is 0.7. So I get 0.7D is equal to $30.80. And so now I'm going to divide both sides by 0.7. And doing that, I can't remember what it turns out to be. I have to apologize. So I'm going to take real quick, 30.8 divided by 0.7 is $44. So the price we're saying was $44. Checking the reduction. Well, if I take 30% of 44, I get $13.20. And so when I subtract, I get that the sale price was indeed $30.80. So it checks. That one all right. Reduction could also be a markdown or a sale. Words that tell you you're subtracting. Next one similar, yet different. Because the next one involves a percent, and we're given the price after that percent is applied, but it's a tax that's being added. So if I let X be the nightly cost, which is what we're looking for, the tax is 5%, 0.05 of multiplied by that. And then the cost plus the tax is $252. Again, these are like terms, so I get 1.05x equals 252. And to solve, I'll divide both sides by that 1.05. Which gives me that X was $240. When I take that and find the tax, when I take that 240 and multiply it by the 5%, my tax is $12. And so it does add to the $252 and it checks. Any questions on that one? With problems like this on a test or quiz, I frequently see careless mistakes. You have to realize that this price includes the tax. So this is the price plus the tax. All right. Not hearing any concerns. I'm going to skip that next one in the interest of time. And look at this one. This is an example of a mixture problem. And there's something that you really have to watch for with these problems, because we're going to solve it with one variable. So as we read it, we're investing $11,000 in two accounts. One pays 5% and the other pays 8%. If the total interest earned for a year was $530, how much was invested at each rate? And so we need to find the amount at 8%, and we need to find the amount at 5%. And the other thing that we need to realize, we need to remember that interest is equal to the amount that we're investing, the principal, times the rate. I want to use variables. I want to solve this algebraically. So I'm going to let the amount at 8% equal X. And now with mixture problems like this, we want to write an expression in terms of X for how much money is invested at 5%. Well, if this $11,000 is my total investment, does it make sense that the amount at 8% plus the amount at 5% would have to equal that 11,000? And so if X is the amount at 8%, and I know they have to add up to 11,000, does it make sense that the amount at 5% would be 11,000 minus X? Is everybody all right with that? Can everybody wrap their minds around that? If so, the interest again is equal to the principal times the rate. And so the interest at 8% would be that 8%, 0.08, times the amount I'm investing, X. The interest at 5% would be that 0.05 times the amount I'm investing, which is the 11,000 minus X. And I know that the total interest is $730. Is everybody comfortable with that equation? Any questions? If not, now that we have it written, we can go ahead and solve it. And so that gives me 0.08x plus distributing here. 550 minus 0.05x equals 730. Combining, I get 0.03x plus 550 is equal to 730. Subtracting the 550, I get 0.03x is 180. And so dividing by 0.03, I would get that x is 6,000. And I'm doubting my division. Yep. And so we'd have $6,000 at 8%, which would give me 6,000 times 0.08. Give me $480 interest. And then if I look at 11,000 minus 6,000, I'd have $5,000 at 5%. And so multiplying, that would give me $250. And so when I look at the total interest, when I add those, I get $730 and it checks. Is that one all right? Any questions? If not, the next one says the length of a rectangular pool is 6 meters less than twice the width. If the pool's perimeter is 126 meters, what are its dimensions? And this is one where, believe it or not, I think that drawing a picture keeps you from making careless mistakes, because we need to remember that the perimeter is the sum of all the sides. The other thing that we need to notice is in this first sentence, the length is being compared to the width. So I'm going to let my variable be the width. And then for the length, I'm told the length is 6 less than, so I'm subtracting 6 from twice the width. Well, that would be 2 times the width, or 2w. To there, is everybody okay? Is everybody all right with using that first sentence? The length is being compared to the width. So that's what tells me my variable will be the width. Going back to my picture then, the width is W. So if this side is W, this side is W. The length is 2W minus 6. If this side is 2W minus 6, this side is 2W minus 6. And again, for the perimeter, I'm going to add all the sides, W plus 2W minus 6 plus 2W minus 6. And I know that that's 126. Combining like terms, I have 6W minus 12 is 126. So I'll add my 12 to both sides, giving me 6W is 138. And then dividing by 6, I get W is 23. So that's my width. My length is twice that minus 6, which would give me 40. And so now if I go back to my rectangle, if this is 23, this is 23, this is 40, this is 40. When I add up my sides, I get 126 and it checks. I know when I was doing this one yesterday with my Tuesday, Thursday class, they were amazed how drawing the rectangle made them realize that they had to add each of the sides twice. Without the picture, they would have made a careless mistake. I started writing too big. How are you folks with this? Any questions? Is everybody all right? If so, I believe that was the last one that I picked out. And so what I'm going to do is I'm going to scroll back to that one that we skipped. And I'm going to ask you folks to please solve this one on your own. I'm going to give you a couple of minutes to work on it. All right. How are we doing? If I let X equal the cost, the markup is 25% of that. And the total is at $15. Combining like terms, I get 1.25x equals 15. And so when I divide, I get x is 12. So if the cost is $12, the markup is 25% of that, or a quarter of that, which would be $3. And it adds to that $15, so it checks. How'd you guys do?
Good.
Good. Any questions? I think the most involved is probably that mixture problem. And I believe there's only one of those on the homework, but you might see one of those again on a test. So take your time with it. I'm going to stop sharing, stop recording.